Hello, I'm Robert, and fact checker and science blogger and helping people who are very scared for Doomsday Debunked booked on Facebook group on Facebook. And I've got these drafts for an article about the Australian bushfires, but I just haven't managed to get it together. It requires a few hours work, and it's been a bit difficult to find the time to do it properly because it's not going to be an easy article to write. So I thought that instead of, since I don't have time to do it quite yet, then I thought I'd just give a video talk about it. And I'm particularly going to talk about a few things that have been worrying people recently in the group. I'm going to start off with this whole news story about 500 million animals lost in Australian bushfires in 2019. Now, sadly, I can't read the original story. It's not a scientific paper. It seems to be a communication by the University of Sydney, which is just being published by the New York Times as a story, the UK Times newspaper as a story, and it's behind a paywall for me. However, it's not at all surprising, these figures, I don't think, because, so let's just give it a bit of context and explain why that's possible. Then there's about 4 million hectares of the forests and bush has burnt down. Then if you had your 500 million animals, that's a little bit less than one animal every 100 square meters. Now, we're not talking about kangaroos, obviously, so that's a 10 meters by 10 meters area, but the loads and loads of tiny little creatures like mice and frogs, and they must be talking about stuff like that to get a number like that. And 10 meters by 10 meters is not really a very big area for a mouse. And you can imagine that with these very severe fires, it might be quite hard for the mice to bury deep enough or to escape. So I think that's probably what they're talking about. Now, this is nothing new, and it's very sad, of course, but this is just the way nature works, sadly. That many of these small animals, they do die. They have quite short lives anyway, and sometimes it's just eaten by predators, and sometimes they just have a short life, and sometimes it would be things like fires and natural disasters. And also in Australia, then from time to time, millions or hundreds of millions of birds will die because it's too hot. The reason is because they are right at the for some of the animals, it's not too hot for humans, but there's lots of variability amongst animals according to their heat tolerances. And for some birds, then it just gets too warm at times. They're right at their warm edge in some places in Australia. And the problem really is they can manage all right in the shade, but they have to go and drink water in order to stay hydrated. And when they go and drink the water is usually exposed and quite hot, and that's when they die of heat death. And so what you can do, if you're in Australia and you want to help the wild creatures there, when it gets very, very hot, then one very useful way to do that, according to the paper that I read on the topic, is to give them a sheltered, not just give them water, but water is in a shaded situation, so they don't have the heat shining on them when they're drinking the water. So if you can provide a shaded source of water for your local birds and other creatures, then this will help them to survive in very hot conditions in Australia. And so anyway, but there's not much you can do to help them with bushfires, sadly, especially when they get very hot, except to stop the fires. And the big problem in Australia is, well, it's very variable. Some years you have lots of fires, some years you don't. But every year, then large areas of Australia do burn. It is part of the natural cycle there, and some years more and some years less. So the aim is not to stop forest fires and bushfires. That's not going to happen. It just wouldn't be Australia without its bushfires. What needs to be done is to make sure it's safe. And it seems that, especially for humans and for vulnerable things there, and the fires don't get too enormously, hugely big. And the fires are needed. The trees, they're adapted. The wildlife, it has habits like, for instance, the koalas. Their instinct in a fire is to clamber up to the top of a tree. And for most of the fires in Australia, when they don't get too big and intense, then they go along the bottom of the trees. And the trees are designed in such a way that the bark burns very, very quickly, so the fire passes through quickly and it doesn't go up the tree. And so the tops of the trees survive, and the koalas, if they climb up into the top of a tree, they survive too. So long as the fires don't get too intense, then the wildlife and the trees too, they survive. And then if the trees do burn down, then the eucalyptus, it grows very, very quickly as trees grow. And within a decade or two, then much of the tree mass is back again. And koalas, they grow very quickly too. Within 12 years, a koala population can triple in size. So although these fires have been a big setback for some of the small local populations of koalas, then given 12 years, then they'll be back again if they've been reduced to, say, a third of what they were before. And in 12 years, and with all the eucalyptus growing very quickly around them, lots of stuff to eat, then they'll be back again. And so this is part of a natural cycle. So I want to talk a little bit, however, it has been made worse by climate change. And so I'm just going to talk a little bit more about some of that. So first of all, what has made these local fires so very bad, and why have they been so dangerous? And it's a bit of a mouthful: pyrocumulonimbus. Cumulonimbus means a thunderstorm, and the pyro at the beginning means fire, so it's a thunderstorm started by a fire. Or it's a type of cloud that typically has thunderstorms, cumulonimbus. And, those kind of dark, heavy, deep clouds. And so what happens is you have a very, very intense fire, large, intense fire. It creates its own weather. And this produces a big updraft, which creates clouds, which causes heavy rain, which would be useful locally for stopping the fire. But sadly, that's just part of it. And you have the lightning starts up new fires. You have big embers carried up in the smoke, and then it lands up to 30 kilometers away and can start a new fire. And then you have the unpredictable winds, mostly in drafts, but winds going all over the place that blow the fire this way and that, and make it very difficult for the firefighters. And sometimes they get trapped because of a new fire that starts, and then wind blows and blows in unexpected ways. And this has been really very hazardous. And as they explained here, this is the Fitzsimmons, who is, it explains out here who he is. He is the RFS Commissioner Shane Fitzsimmons, and he gave his update, and he talked here about all the challenges, the hot and dangerous conditions, that the smoke and the fires and the updrafts, it's not easy to fly. They just couldn't fly some of their sport helicopters and planes, and then you have the dry landscape and drought affected, and then a significant amount of this pyroconvective activity and the tragic consequences, because it's very, very hard to firefighters to deal with these conditions and fight the fires at the same time that they have all this stuff going on. So that's what's been going on, and that's partly why it's been so difficult and so dangerous. Now, this is nothing new. Pyrocumulonimbus clouds, they're not new to Australia. It's always had them. So it's not like it's a uniquely dangerous situation just now. It's just that this is a particularly bad year, but they've had bad years in the past. He says there that it's the worst in New... make sure I got the right condition. In New South Wales, it's the worst fire experience. It has to be one of the worst, if not the worst fire seasons that they have experienced. That's presumably in living memory in New South Wales. So it has been very severe. But these things do happen from time to time. However, it is also true that global warming, the slight increase in temperature of global warming, increases the risk of this particular kind of storm. And this is a paper about how the risk increases. This is the number of days during which there is a significant risk, and the number of days in the year when there is a significant risk of bioconvective risk factors in extreme weather increases by up to 50 days in the year under high emissions by 2100. You could have 50 more days in the year in the worst areas of Australia of risk factors like this. So global warming is going to make a significant difference, and it's going to be very important. As hopefully we're not actually headed for such a bad condition as that. That is business as usual, and we are headed for less than that, a degree of warming less than that already with the pledges so far. So we have taken some of the risk of that already with the Paris Agreement pledges so far. But it is going to be an increasing factor. And so anyway, so the other strange thing that would be quite unexpected for you maybe about the Australia is the way that the conditions change so very much from one year to the next. For instance, and this is one of the worst years, 1974 to 5, you had a dry year then, and then the Northern Territory is the worst, with about half of it burns every year. But this is part of the natural cycle there. The trees are adapted. So if we go back and look at this picture of the trees here, just to have a picture to remind ourselves, then the trees in Australia, they are adapted to fires, and as long as the fire doesn't get too intense, then the bark of the trees just burns off very quickly, and the fire continues in the undergrowth, and the upper parts of the trees can stay green. And koalas have this reflex behaviour, which sadly doesn't work at all well with the very severe fires, is they climb up to the top of the trees, and if it's not such a severe fire, then it'll pass through underneath them and they will survive. They're very, very slow moving, so that's the safest thing for them to do. They can't outrun the fire, but if they climb up to the top of a tree, then if it's not too severe, then they will survive the fire. But in the severe fires that they've had, with the canopies burning, then of course the koalas die, and and only a third of them are left. However, even with these severe fires, then and this is just in the worst affected areas, then even with these severe fires that led to so many koalas dying, then the koalas, their population does increase, not as fast as say mice or something like that, but it increases. It does increase fast enough so that within 12 years the population can triple, especially since the trees will be growing again. The eucalyptus is growing very, very fast. A very fast growing tree as well. So talk about the future fire changes. So then I want to talk a little bit about I'm getting a bit confused. Hopefully I'm not repeating myself. So I'm going to explain about how the Australian dry and wet seasons, how they alternate so much. And it's actually not necessarily in the wet season, although it is this time at the worst fires. In 1974 to 5, it's after heavy rain that you got these very, and it was still a wet, moist season. But these huge changes in climate, and they happen because of this Indian Ocean dipole. And so what happens? A normal condition, then the temperature is pretty much constant across. Let's move me over to the other side. then the temperature is almost constant across the ocean, across the Indian Ocean. But then in a positive phase, then you get this situation where you have increased warmth there, increased convection, and you have it cooler here. And then the cool air holds less moisture, and this leads to drier conditions in Australia. And this happens when the westerlies are rather weak in this direction. But then when the westerlies get rather strong and intensify along the equator, then you get cooling there, you get a warming there, and you get increased convection. I don't really quite follow all the details of how this works, but you get increased convection north of Australia, get these warm conditions, and then this is warm and it's moist and increases the amount of rain in Australia. And so it is this condition, these changes in conditions, is which continue flopping back and forth, that makes a difference to the Australian. It makes this one of the main factors, apparently, in the Australian conditions there. And so anyway, whatever the reason, you can see how it's continually flip-flopping. Sometimes very, very wet, and soon after it's quite dry. So it's very moist, and a lot of rain and moist is the blue, and red is when it's very dry. And it's been doing that for decades. It's been doing that since forever. For long before humans were in Australia. And when the Aborigines were the main kind of looking after land over most of Australia, then they did a lot of controlled burning. And in some of the nature reserve, where they're trying to restore original conditions, they actually have some of the Aborigines using their original knowledge of how to set the fires and so on, to do this controlled burning. And that is what you need in Australia. The reason we have these huge bushfires, basically, is because they've stopped doing the controlled burning. And that is part of the factor. And it's quite important to do quite a bit of burning and make sure that you don't have long periods with the forest growing and growing and growing, then all burning in very intense fires. So that's a factor as well. And so there's more controlled burning is needed, more care on the fires, and then dealing with the fires as they arise very quickly, and lots of firefighters, and lots of very rapid response to the fires. And they're going to have to increase the firefighting force in Australia in one way or another, and the discussion is about how to do that and how to make it more effective in the future. And so now what else have I not covered here? So so about the long-term effect, and people worry. So for instance, now this is my best diagram down here somewhere. Let me find. There we are. So as with climate change, then we're going to have changes in the some areas of the world will get drier and some will get wetter, and the roughly speaking, these green areas are getting somewhat wetter, and the red areas are getting drier. But it's not a very complete picture, because, for instance, large parts of India are facing dry conditions in the dry season because of problems with the glaciers, and the glaciers are going to be melting later on in the season. But this is just about the kind of dryness and wetness. And so, as you can see there, Australia is really pretty much uniformly going to be getting quite a bit drier, and as the temperatures warm. But you can parts of Brazil are as well, and this is like so kind of based. This is something that we can work with, and we can counteract. We can reverse. We can stop. Like for instance, in parts of Spain and Turkey it's quite severe, because it's already, what matters most for areas that are already arid. The rainforest is naturally quite resistant, actually, and this area, you're not going to lose your rainforest, even in a drier, warmer climate. But further south, then there is more of a risk of losing large areas of rainforest to savanna, but not to desert. And this is depending how warm you get. So parts of Australia, a rainforest, they're just going to be staying as rainforest, and the wet forests along the coast, they'll stay as forest. But some of the dry areas, then they can move from semi-arid to desert. And but you can do a lot to prevent that and reverse it. And there's an awful lot of reforestation going on, and you can look at the examples of India, for instance, where although it's getting drier, they're actually getting more crops. They're doing 2 crops a year instead of 1. China is doing a lot of reversing of, it's actually getting drier, but it's doing a lot of reversing of desertification and planting of lots of forests and things. Over all of the world except South America and Sub-Saharan Africa, we actually have a net increase in forests because of large reforestation campaigns. And even though the large reforestation is here as well, we're getting a lot of deforestation, but hopefully in the mid-2020s we can turn that around, so that it's no longer deforesting and it's going back to reforest. And so Australia needs to do something like that. It needs to turn things around and really works carefully on reversing this aridification and slowing it down and stopping it. And you can do it by different forms of farming and different ways of managing the land. So this is not something where you just need to sit back helplessly and everything's going to become more desert. In fact, some areas are going to become wetter anyway, naturally, and the areas that are projected to become more desert, then in many of those areas we can do things to stop it or slow it down. And they're doing that in areas in Australia and working out ways, and of course also large areas of Australia, then they've been rather mismanaged by humans, and they haven't worked with the native local vegetation as well as the original Australian Aborigines did, and there's a case of learning to work better with the landscape and improve agriculture and improve agricultural methods in Australia. Just because it's an advanced industrial nation doesn't mean that it can't also improve the ways it does agriculture and do more agriculture that's more suited to the conditions there. And people are still learning things in Australia about the best ways of doing that. And there are quite a few schemes involved in doing things and learning better ways to do agriculture and better ways to look after the forests. So I'm saying this because some people just are saying, oh, this is the end, we're going to have to evacuate Australia or something. No, it's not that at all. And it's not going to get too hot for humans. So although 40 degrees centigrade sounds extremely hot, it's not really. It's because human beings, we can sweat, we can deal with dry conditions as long as it's not too humid. Now, 40 degrees C with 100% humidity, we just couldn't survive that. You can't survive 38 degrees C. And even at 35 degrees C, it's very difficult conditions if you have 100% humidity. But when you have very humid conditions, you have clouds, you have rain, and it's naturally cooler. So the world as it is now, it simply doesn't have anywhere that is too hot for humans. It gets within a few degrees, but it doesn't get to that point. And it's only going to be at about 4 degrees centigrade, and starting in the paddy fields in China, because it's so humid there, and other humid areas in India, Persian Gulf, maybe from Florida, although I couldn't find a paper on that particularly, but that's very humid as well. And you can imagine these would be places where at about 4 degrees centigrade, then it'd be really quite difficult for humans to survive. Remember, humans and animals all have different tolerances, so it doesn't mean it's going to be too hot for life. There'll be plenty of life there. Even at above 4 degrees centigrade, you'll still be able to grow your rice. if you can just, maybe with air conditioning. It's just that it's too hot for us with our particular metabolism at about 4 degrees centigrade. Then at 4 degrees centigrade, it's not too hot for humans to survive, even at 100% humidity. If in the paddy fields, as long as you can go indoors and get away from the very humid conditions, even without air conditioning. But gradually then, but you wouldn't want after about 6 hours or something in the fields. So anyway, these are not a situation that we expect to be headed for. In Australia, then it's not an issue. Australia is not going to become too hot for humans, not at the 3 degree path that we're on. And it's really a question of what kind of conditions people want to stay in and how much work they need to put into it. And Australia is very high technology, and there's lots of resources, and there's no doubt at all that the Australian population can stay there, and they can do a lot to make conditions much easier for the wildlife. And it's just a few degrees increase. It certainly is not going to mean humans or evacuating Australia. And people worry about the koala bears. The koala bears are going to be, as the world gets warmer, this is the current population of the koala bears. And some areas of them, they're not at all at risk of extinction at all. They're never going to become extinct because koalas can reproduce very easily in captivity. And some areas of Australia, this is not published, you don't get so much news about this, but for instance, estimated as of May 2019 to be 150,000 koalas in the Mount Lofty ranges, and there they use contraceptive because there are too many of them. They damage the bush, they harm the trees, and there are just too many of them. They need contraceptives to reduce the population. So they actually are a pest there, really. There's so many of them. And so anyway, there is no risk of, there is risk for certain small populations of koalas, and lots of regions that used to have koalas that either don't have them or have much fewer of them. And that is where there's a lot of concern. But there isn't, at the moment, it is only borderline vulnerable. There was some dispute about whether to even classify it as being vulnerable, the koalas, because they're just very, very borderline, and that means just means like a 10% risk of extinction by 2100, but not for the koalas. They don't really have risk like that, and there's no way they're going to become extinct in the wild by 2100. But in a warmer world, they're going to contract eastwards and southwards, and they may also find new habitats in Tasmania and southwest Australia. So if we go back to this map here, where was it? Oh no, it's further down. Then they're going to contract this way and this way. They may also find some new habitats there. And where was the other region? I just said it, but I've forgotten what I said. And New South Wales and Victoria, or where Queensland. Isn't that further to the? I'm a bit hazy about my Australia. Let's bring up Queensland. I think isn't that the southwest? Am I getting mixed up? Let me just Queensland. I've just pinged that up and then have a look at it on the map. A map. Oh no, that's up there. Oh sorry, I got it completely wrong. So they could have new range up there, and then New South Wales. So there's the possibility of new habitats up there as it gets warmer. Tasmania. Oh no, oh sorry, I got it upside down, yes. They're going to contract in Queensland, and that makes a lot more sense. Yes, they're going to contract in Queensland and New South Wales. That makes sense, that area. And then they're going to colonise, and in the warmer world, they will find new habitats in Tasmania and in southwest Australia. Right, that's it. So contracting there, move to the east, moving to the south, and then finding new habitats there, and finding new habitats there. That makes a lot more sense. It doesn't make sense they go the other way. So that's the situation for the koalas in a warming world. They're not going to go extinct. And this whole idea of them being functionally extinct, it doesn't really make sense. It's the Australian Koala Foundation. They're a little bit activist, and they say these somewhat exaggerated things. I don't think it actually really makes sense what they say. It doesn't match at all what the scientists say in their big surveys. They have a strange way of counting the koalas. They only count the ones, well, I talk about it in my drafts. They only count the ones that they think are kind of especially healthy populations, and they discount other ones that they don't think are so healthy, and they're rather eccentric in how they do all that. And so they have much lower numbers of koalas because a lot of the population they don't even count for rather eccentric reasons. And then those are the ones that get publicised, and then they say that they're functionally extinct, which normally is taken as meaning that they can't even produce a new generation, which is absolutely obviously not what they mean. It's another alternative, rather fuzzy definition that is what they seem to mean. But in the short of it, long and short of it is, there is no risk at all of extinction in the wild. There is risk of losing some of the smaller, more vulnerable populations of koalas. Now, is there anything else that I haven't covered in this bit? I was just going to talk a little bit about how they do their fires, but this various terminology. They make these control lines where they kind of clear the ground, and then they, in cooler, drier conditions, then which they had a little bit over Christmas, then they burn back from these control lines towards the fire, and they and that's called a backburn. They cut the electrical power supply to buildings in order to stop those causing fires. So quite a lot of things that they've been doing, but there's it's been such extreme conditions, and really it's only really when it's going to be months from now before these fires eventually stop completely, and that's just the situation. It's just so difficult and to deal with. But it's not the first time that Australia has had fires as bad as that. It is apparently the first time it has been so bad in New South Wales, in living memory of the firefighters. Anything else that I have to cover? Oh, I was just going to talk, although this is about desalination, and you can use that for water supply. I'm not quite sure why I put that in there, but there are various ways of dealing with the conditions in Australia, and I would have to find it and bring it up. But one of the ingenious methods that is actually being pioneered in Australia is using saltwater greenhouses. It wasn't originated in Australia. It's not an Australian idea originally, but it is. They're involved in a very early stage development of it. There's the Sundrop farms, where they have greenhouses in a desert, and then they pipe in salt water from the sea. Lots of areas of desert are quite close to the sea, so it's practical to do that. And then the heat evaporates the water from the salt. It's just like the salt pans, where you have natural collection of salt, but they do it inside greenhouses. The water vapor then fills the greenhouse, and then this is the same as irrigating the tomatoes or whatever you've got inside. you get salt as a byproduct, just like you do for salt pans. It's basically an enclosed salt pan, a salt pan enclosed with artificial salt pan, enclosed with greenhouses covering it. And then you get the salt as a valuable byproduct, and lots of things in the salt, like metals and so on, that you can extract. And then you get the water that irrigates your crops, and then you have moist air comes out into the desert, and it turns the desert green around the greenhouses as well. And so this is one of the more high-tech ways that you can actually improve conditions in Australia in the deserts, grow crops in the deserts, and actually bring water into the desert from salt water without having to have big expensive desalination plants. You just pipe salt water into these kind of artificial salt pans, and then you grow plants in the humid air enclosed by the greenhouses, and then you have the salt as a byproduct. It's rather a clever, ingenious idea that is beginning to take off in Australia. And there's new ways of managing the land, and basically the big thing there is to slow down the rate at which rivers go down towards the sea, and that traps more water into the land, and then that makes it more, you can have more retaining of the moisture, and then you can have the land go green again. And then when you've got trees, then that actually increases the humidity, increases the rain. It's kind of a virtuous cycle that helps the situation in Australia. And just as in everywhere, reversing desertification where that has happened, then that is something you can do in Australia too. And so there's a lot we can do to actually improve the natural situation in Australia. There's lots of conservation work being done to protect the native Australian species. I've talked about that separately in other debunk. With the corals, there's actually a lot of work being done. Both, of course, we need to stop the CO2 emissions to stop temperatures getting so high, but there's also work being done to be able to help improve the corals and make it easier for them to adapt to warmer conditions. And it's not an absolute edge. The corals in the Great Barrier Reef are not adapted to even a very slight increase in the warmest temperatures because it's so constant temperature there. But there are other corals, even in Australia, there are other corals in other parts of Australia that can withstand higher temperatures by some degrees, over a degree or two, I'd have to look up the figures, over the ones in the Great Barrier Reef. And in quite extreme conditions where it's near the coast, where you have tidal changes and big changes in temperature, and the highest temperatures there are higher, and the much higher temperatures are also can be withstood by corals in the Red Sea. The problem is that you can't just take a coral reef and move it en masse to a different situation. The obvious solution, in a way, if you could kind of teleport reefs or something, would be just to take the Great Barrier Reef and teleport it to, if you had like the Star Trek transporter, then you transport the Great Barrier Reef, just transport it to a somewhat cooler area of the ocean. Everything would be hunky-dory. And if you can arrange that the rest of the sea around that is, it's a very appropriate situation for everything, and it's not going to be invasive species or anything. But we can't do that. It's just not feasible to move an entire coral reef. So we have to help the coral reefs in situ, and you need to work mainly with native corals, and then take the corals and help them in a laboratory and return them. So there are ways we can make them more resilient, but it's also very important to, and given a couple of centuries, the coral will adapt. There's no doubt about it. But the question is whether it can adapt in just a couple of decades, and that's far, far more of a challenge. That's why they talk about probably losing just about all of the Great Barrier Reef if we had a 2-degree sea rise. But that not that it turns to a desert, but it turns into sponges and seaweed and stuff like that. But there is work that we can do to stop that happening, and if we can stay within 1.5 degrees C, then things will be much, much easier. And by the way, I don't know how many of you know this, But the Great Barrier Reef, originally biologists had no idea at all how important it was biologically. It's the 1970s, I think, or something like that. And there was a plan to just mine these people who wanted to mine the corals. They said, look, this area is basically dead. Most of it is coral, and of course if you look at the coral, only the surface is alive, the rest is all dead. And they said, we'll just mine all this limestone. I mean, nothing's using it. It's got a little thin veneer of stuff on the top of it. We'll mine all this limestone and use it for building. And they were going to just basically dig up the whole Great Barrier Reef. They started with one reef they had their eye on, but they would have done the whole thing. And then just shipped it all away to the rest of the world. And if that had happened, then we wouldn't have had the Great Barrier Reef by now. It would all just been turned into cement. But some biologists said, wait a minute, we haven't had a look at this yet. It might be interesting. And then they went and had a close look at the Great Barrier Reef, and they reported back, oh, this is astounding what we've got here. There's a huge amount of variety. And then they start being very activist and saying to everyone, we can't let this go ahead. And so that is basically the story about how the Great Barrier Reef was saved for our generation. So we have to do the same and save the Great Barrier Reef for the next generation, for a rather different challenge. We no longer have people who think it's a good idea to cart it all away and use it as a cheap source of cement for making the foundations for buildings. But we do still have issues with climate change and adaptation and wanting to reduce CO2 emissions. Anyway, I could go on and talk, but I hope that this has dealt with some of the main things, and that I know some of you are watching this. You actually are in Australia and you're experiencing these fires, and it must be really difficult, especially if you're in one of these areas where you're cut off by the fires all around you, and you can't move, you can't leave your area, and it is a difficult situation for sure. But perhaps what I've explained, giving kind of longer term perspective, can help you kind of see it. It's not like the end of Australia or anything like that. And there's lots that is being done and can be done, and the fires are actually a natural part. And if you're going back and read the very early history of the Australian settlers, then you will find that they faced very severe fires at times, and that was right at the early on, before they had organised the firefighting. They just didn't have a clue about the need to that not just one person looking after their house, but having to organise large groups of people to work together to fight these fires. And in the early days, they didn't know that, and they had very severe fires and lots of people dying. And we've gotten very much better at firefighting now, and we know what to do, but they've been caught a bit unawares, and they haven't got enough firefighters, and it's a somewhat similar transition that we have to do now to what the early Australian settlers had to do when they first started to realise, yes, we have to have a firefighting force. Now we do have firefighting forces in Australia, but we need to up the game, and we need to do new things and be innovative and work in being very much more proactive in stopping the fires, in reducing the and in doing controlled burning, an awful lot more of that, so that you don't have the bush in the first place and growing so much as to have so much fuel for these fires, and also things like carefully maintaining fire breaks along the roads, because a well-maintained road with cut back fire breaks all the way along, then that stops the fires. A badly maintained road with bush on either side actually becomes like a little fuse to actually carry the fire wherever the road goes, and helps to spread the fires. So in the research that I was reading, that was one of the things that they were saying: make sure that your roads have good broad fire breaks on either side. and that you maintain them well. And I mean, lots of things, and they're still learning. They're doing lots, and there's still more that the people who write about this. They still have recommendations of ways that firefighting can be improved in Australia, and they do need more firefighters, and there's a question of how that's going to be financed, and how that's going to be done, as well as the volunteers and the paid firefighters and the more equipment and so on. Anyway, so I hope this has helped a bit.